Our world is not always the same. Hidden from our view lies a different world. Creatures utterly unlike us. Almost alien. Yet they are more numerous than any other group on the planet. Welcome to the fascinating world of the arthropods. Spiders, scorpions, and insects. Today, we have new camera techniques that will allow us to reveal in greater detail than ever before their lives, the way they fight and feed and reproduce. This series uses specially developed 3D camera technology to study the micro-world in extraordinary detail, both on location and in specially constructed environments. We'll witness their births, the challenges they face, and the moments when their lives hang in the balance. And that may help us understand how it is that today, over 80% of all animal species on this planet are arthropods. In this series, we'll see the way they have evolved, from the comparative simplicity of the millipede to vast colonies that contain hundreds, even millions of individuals. We'll witness the most extraordinary transformations in the animal kingdom. We'll meet ants that farm, spiders that can cast their webs, and the bug that wears the bodies of its victims as a disguise. Welcome to a strange and dangerous world. Of all the arthropod adaptations, the most revolutionary has been the ability to live in immense colonies. That enables them to hunt en masse, to build huge constructions for a home, and to dominate their surroundings. Some colonies are quite small. Others contain as many individuals as our largest cities. If great numbers of individuals are to work together, they need to be able to communicate, to pass on information and instructions. And doing that enables them to maintain farms, to plunder the forest floor like an invading army, and to build immense castles. Honeybee workers are able to send complex messages to one another. In the wild, they sometimes nest out in the open, but mankind has persuaded them to live and store their honey in hives. The colony's heart is its queen. She is just a little bigger than her subjects and mother of them all. In spring, when food stocks are low, the workers get busy collecting nectar. They have a remarkable method of telling one another where to find the most productive flowers. It's called the waggle dance. This returning bee has just found a new source of nectar and is going to tell others in the hive about it. First, she gathers an audience. To do that, she climbs on her sisters' backs and vibrates her abdomen. Now that she's got their attention, she begins her dance, using a code of movements that tell her fellow workers where her discovery lies. The duration of her waggle indicates the distance to the nectar source. The longer the waggle, the further the flower. And the angle at which she dances across the comb tells them the direction to the flower in relation to the sun. Her instructions are remarkably accurate and can pinpoint the location of a nectar source over 6 kilometers away. Some of her fellow workers set off immediately to find it. In one short season, the colony's workers will visit up to 500 million flowers and will make around 90 kilograms of honey. That is sufficient to sustain the whole colony through the coming winter when there is no nectar to be had. But dancing can only communicate with a small number of individuals. In the forests of Africa, there are communities 1,000 times larger than that. For much of the time, they're dispersed, ranging through the forest in dozens of columns, searching for prey. A driver ant colony may contain 50 million individuals, and they're virtually all blind. Their community has no permanent home, just a series of temporary bivouacs. The horde is coordinated by the queen. Unlike her honeybee equivalent, she is many times larger than her workers. Her size enables her to produce at least 120,000 eggs a day. She is tended by the workers when in a bivouac and carried by them when the time comes to move on. Soldiers with huge jaws guard the traveling workers and attack prey when they find it. A colony of 50 million needs a lot of food. The ants communicate by releasing and smelling chemicals called pheromones. Earlier in the day, a scout found a good hunting site and marked out a path to it by laying a trail of pheromones on the ground. The hunters followed the trail, sensing it with their antennae. Soldiers guard the flanks of the rushing column, while the smaller workers who will butcher and transport their victims run down the middle. Those at the head of the column will tackle anything that is too slow to escape. They have found a slug and released a different pheromone, this time into the air, signaling that they need help. Workers and soldiers from all over the area rush in for the kill. The soldiers' powerful jaws slice into the slug. Fragments of it are sent back to the queen and workers waiting in the bivouac. And within minutes, nothing is left of the slug. By communicating with pheromones, a colony scouring the forest can collect hundreds of thousands of victims in a day. That is enough to keep the queen and her millions of subjects well fed. So she can continue on her own particular task of producing enough offspring to maintain the size of the community. Not far from the driver ants' forests, out on Kenya's savannas, another colonial insect collaborates, not to hunt, but to build. Their spectacular constructions dot the open sun-baked plains. An organized community of millions can only work if individuals within it can communicate with one another. Out on the sun-baked floor of the Rift Valley in East Africa, daytime temperatures can rise to 40 degrees or more, and there's little or no shade. So the termites that live there make it for themselves. They build air-conditioned castles. The queen lives in a special chamber about a meter below the surface of the ground. By her side, a single fertile male, her king, the father of the colony. Her pale, fleshy abdomen is distended with eggs. Her tiny head dwarfed by her huge body. Soldiers guard the royal chamber, their pincers raised, ready to tackle intruders. She's so huge she can't move by herself and has to be tended by specialist workers who continually groom her. She produces eggs almost continuously. Attendant workers take them away as soon as they arrive. She can lay thousands a day, 165 million over her 15-year life. But to produce this prodigious number, she needs perfect conditions, a steady temperature and a constant supply of well-oxygenated air. If she doesn't get that, she will die, and with her, the colony. Since she herself can't move, the workers have to create the conditions that suit her. And they've done so by building an air conditioning system, a maze of chimneys and towers that stand above her chamber. It can be 9 meters tall. But despite the mound's huge size, not a single termite lives in it permanently. They stay underground. The sides of the castle are studded with holes. Animations show how gusts of wind move across the savannah. Hot air blows into these entry holes. The ventilation passages within have many twists and turns that slow down the air, and as it slows, beyond the reach of the sun's rays, it cools. The fresh air, dispersing through the mound, displaces the old, stale air. Outside, it's over 40 degrees centigrade, but in the Queen's underground chamber, a comfortable 27. Working together, these tiny insects have created a cool, air-conditioned home. Something they could never have done working as separate individuals. In Central and South America, in the rainforests, other immense insect communities have achieved something perhaps even more remarkable. These are leafcutter ants, and their underground nests are gigantic. They can be 30 meters across and contain 8 million individuals. And they owe their success to something they devised long, long before we did: agriculture. Leafcutters have found a way of harvesting the vast proliferation of leaves produced by the forest trees. They remove them piece by piece. But they don't eat them. In fact, they can't even digest them. The leaves are fodder for their underground farms. Like all complex colonies, the leafcutters have a central organizing individual. Their queen is many times larger than the workers. When she founded the colony, she brought with her a tiny piece of fungus that now grows in gardens throughout the nest. As it grows, the fungus produces little white, knob-like structures which are full of nutrients, which the ants can digest. Out in the forest, foragers cut the leaves into segments and carry them back to the nest. They have sharp, powerful jaws which slice through the toughest leaves. The pieces they cut can be as much as 50 times their own body weight. They can be so heavy that sometimes only the larger major caste of the ants can lift them. Their nest may be up to 120 meters away, a very long distance for a porter that is only a centimeter long. Here, the smallest caste of ants in the community, the minims, are hard at work in the underground gardens. They receive the leaves from the foragers, chew them up and feed them to the fungus. They're very fastidious and constantly check to make sure that the gardens are kept clean and properly watered. They also control the quality of the leaves sent to them by the workers. If it suits them, they release a pheromone which encourages the workers to cut more. If they dislike what they're getting, they release a different pheromone that stops the collection of that kind of leaf. A single colony of some 8 million individuals can harvest a fifth of the new leaves grown each year by the trees in the surrounding forest. Millions of closely related individuals have become a single, integrated superorganism. The arthropods are the most successful animals on the planet. We already know of over 1 million different species, and we're discovering more every day. And the reason is quite simple. They've had over 400 million years in which to evolve new ways of feeding and fighting and collaborating. And the result is the dazzling range of species that we see on Earth today. Quite simply, the arthropods are the most successful kind of animal on this planet. In this series, new technology has enabled us to look at arthropods in a different way and reveal how they have adapted over hundreds of millions of years. From the simple, solitary lifestyle of the millipede to the vast colonies containing millions of individuals. We have traced the fascinating techniques they've evolved in order to survive. From the gruesome disguise of the assassin bug to the bombardier beetle's superheated defenses. We've seen how a wasp can subdue a cockroach and turn it into a helpless living food source for her young. Watch the extraordinary mating dance of the scorpion and the praying mantis that sacrifices his life in order to reproduce. All are the product of the same simple drives that underpin all life. The need to eat, to survive, and to reproduce. Some care for their young. Others transform themselves in order to find a mate. And some create gigantic communities that numerically rival our greatest cities. And thanks to today's extraordinary technology, we're beginning to understand them better. We like to think that we share the planet with the arthropods, but you could argue that this planet is more theirs than ours.
And David Attenborough will be back next year, but stay with us for a fascinating insight into how Micro Monsters was made. That's in a couple of minutes on Sky One HD. Or join him in the Galapagos over on Sky 3D, where he meets the legendary giant tortoise, Lonesome George.